Hello, everyone. Let's get started. We will continue from where we left off last week. We won't be able to finish the entire lecture today, but we will get through most of it, okay? And whatever we don't finish, we will certainly finish that next week. We do have the quiz number 1 next week, and when more people come to class, I will explain what's on the quiz and what to expect. Okay, so this is where we left off last time. We had two concept check questions that we didn't have a chance to go through yet. So let's take a look. Sucrose is made up of which of the following sugar? Okay, so we learned that carbohydrates are made up of these individual building blocks, right? And they include things like glucose, fructose, and galactose. Okay, these are monomers, and we can connect different monomers together. Okay, does anybody remember the name of the process that is involved in connecting the monomers together? Okay, these are
monosaccharide.
okay, yeah. These are monosaccharides, that's right. They are the single sugar, but I want to know the process by which we connect them together. If I take a glucose and another glucose and I want to link them together,
Disaccharide.
yeah, they will become disaccharide, but the process that connects them together. Anybody know what I'm talking about here? No, that's okay. So it's dehydration synthesis, right? And that's the reaction to put them together. So glucose plus glucose will give you maltose, and you have to know this for your quiz, right? Fructose, glucose will give you sucrose, and galactose plus glucose will give you lactose. So these are disaccharide. Okay, and we connect the monosaccharides together using dehydration synthesis. And of course, each one of them would create a water molecule, right? So here, the question is asking, sucrose is made up of which of the following sugars? So the correct answer would be D. Glucose plus fructose is going to give you sucrose. Is that okay? Does anybody have any question here? Something stuck on my glasses, sorry. All right, let's try the next one. Now, the next one is an example of a multi-select question. Okay, so you will have some of those on the quiz where you have to answer, you will have to select more than one correct answer. So I'll give you a moment to take a look at that, and then I will launch the poll for you to try in a second. Some of you are telling me if I launch the poll too quickly, it's going to be blocking your browser or something, right? Okay, so try that. Okay, I'm going to launch the poll for you. Sorry, my display is a little bit off here. Okay, there we go. All right. Anyone else? I only got 9 responses. I'm gonna close the poll soon. Okay, that's it. Thank you for participating. So all these questions are about polysaccharides, right? So we have 4 types of polysaccharides: glycogen, starch, right? These are for energy storage. Glycogen is for animals, starch is for plants. And we also learned about chitin and cellulose, right? These are for structure, right? So with that in mind, let's take a look at our choices. Polysaccharides are important both for energy storage and to provide structure to cells. That's correct. Okay. So we're looking for the false one, right? Glycogen is important both for energy storage and to provide structure for a cell. That is incorrect. Glycogen is only for energy storage, does not provide structure for cells. Cellulose is only found in animals. That's not true. Right? It's found in plants, not in animals. We don't have cellulose. Okay. Glucose, fructose, galactose are examples of monosaccharides. We wrote that down on the previous slide. Starch is a storage polysaccharide made by plant cells. That is also correct. So the answer would be B and C. So for multi-select questions, you would have to choose all the correct answer to get full marks. They are 2 marks each. All right. Now I think almost, oops, we just lost someone. I was gonna say, I think everybody is here. The usual attendees are here. So I'm gonna tell you about the quiz next week, okay? The quiz next week is going to be on Thursday, and it's going to be available from 6 a.m. to 11:59 p.m., which means you can access the quiz during the entire day, pretty much, right? Starting at 6 a.m. We still have class next Thursday. You still have to come for the regular test hours, okay? So like you might want to do the quiz between your morning math class and my class. You will have some time to do it, right? Or you can do it at night, or you can do it first thing in the morning. It doesn't matter, okay? But you have to come to class. Don't skip class. The quiz will have, you want to write this down, but I'll post it up after class as well, okay? There will be 2 short answer questions. Okay, you have to type the answer out. And both of the short answer questions will be based on lecture 1 only. Okay, the scientific method stuff that we did. And then there will be 17 multiple choice questions. They are from both lecture 1 and lecture 2. And then there will be 5 multi-select questions. Multi-select question or MS questions are questions with more than 1 correct answer. Okay, they could have 2, 3, 4 correct answers. Okay, you have to take a look. You will know it's a multi-select question because it will tell you to choose all the correct answers. Okay, so it will be 45 minutes and you will have to use the lockdown browser. And this is an important point. Okay, for those of you who maybe missed the first class or something, when you do use the lockdown browser for quizzes, everything on your computer is locked. You won't be able to open any files. You won't be able to go on the internet. You won't be able to see your notes. Okay? So if you want to use your notes, and I reiterate, it's okay to use your notes. If you want to use the notes, you have to have a physical copy of it, right? Because if it's all PowerPoints and PDFs on your file on the computer, you won't be able to see them during the quiz. You understand that? Okay. So like print it out, even better, write a page of cheat sheet or something that would help you have quick reference to things that you don't remember. Does that make sense?
Yes.
Okay, thank you, BB. But does anyone else have any question regarding the quiz, the format, and how to go about it?
Yes, please. Just one question. Sorry, I think I misheard you. So there is 2 short answer questions on lecture 1, 17 multiple choice,
Yep.
and that's lecture
1 and 2.
1 and 2.
Uh-huh.
And then
That's
how many multiple select
5. Yeah, these are also from lecture 1 and 2 together. Okay.
1 and 2.
Yeah, I will post this information online. Yeah.
Oh,
So
thank you.
to access the quiz, I will post a link on the eCentennial as well. Okay, under news item, you will see it. Now, if you require extra time because you have a special accommodation need, you have to contact the Center for Accessible Learning and Counseling Service. We call them CALS for short, CALCS. You need to book an appointment with them, get the proper documentation, send it to me, and then I will give you the extra time. All right, I'll post a link after class on eCentennial as well. For those of you who don't know what that service is.
The extra time, is it like time extension or?
Yeah, extra time would be for students who have special learning needs, right? So if you know, have certain form of learning disabilities, for example, that requires you to have extra time, then you need to get the proper documentation with again CALS, CALCS, and then once I receive the documentation, I will give you the extra time that is needed. Okay. Now, on the note of the evaluations, there's something that you guys should be aware. After the quiz, you will get your marks on the next day, okay? But you will not be able to see your quiz, okay? So you don't have to email me and ask me, can I see which question I got wrong? I won't be able to do that, okay? As a department, we decided that for online learning, we have to maintain the integrity of the test bank. So we can't let you see the question because we don't want it to end up, being leaked online or something like that, right? Because we know there are websites that people can post assignments and test questions on, and we don't want that. So that's why you won't be able to see your test results. You will have your final score, but you won't know which question you got wrong. I know that is not ideal for learning, but that's the constraint of online courses. All right. Now, if there are no additional questions, I'm going to get back to the lecture. Last call. Anything else? All right. Well, if you think of anything, yeah. Sorry, go ahead. Yeah.
Sorry. Once we are done with this first quiz, like we won't go back to it for the second quiz, right?
Second quiz will be on lecture 3 and 4, but then your test number 1 will also include lecture 1, 2 as well. Okay.
But after we've done the
but
quiz,
after the test, it will be no
again.
more. That's right. After the test, it will be no more.
Yeah. Thank you so much.
All right. Well, if you guys think of anything else, you can private message me if you want, or like send me an email.
Okay.
Blessing, you have a question?
Yes, I'm new to the class.
Oh,
Where
welcome.
Thank you. Where can I download it? Is there a textbook for this class?
So I will show you. Stay a little bit after class. I'll show you where to find the recordings of the class that you've missed. In those recordings, you will find all the information you need. Like the short answer is no, there's no textbook. Okay.
Okay.
But you can watch those recordings and find out where to find resources, lecture notes, and so on and so forth. All right.
Okay, thank you.
Okay, no problem. Let's go back to the lecture now. So we learned the first type of macromolecules, which is like carbohydrates, and now we're going to move on to the second type. Now it's confusing, I know, so many new terms, so many new concepts. So before we dive into the lipids, I want to write this down for you, and you should maybe, just copy it down and keep it next to you. It will help you keep track of what exactly we're talking about. All right, so under lipids, there are 4 types that we will discuss. The first one is fat. Okay, fat has a fancy name, which is called triglyceride. Triglyceride. It's like fancy word for fat. There's like a lot of complicated terms for simple things in biology, unfortunately. Now, there are 2 types of fat molecule, 2 types of triglyceride. First one is saturated fat, and then the other is unsaturated fat. You don't have to know what it means right now. I'll explain. I'm just showing you the different categories. So as we go through them, You know where we are at. That's all. The second kind of lipids that we will look at is phospholipid. Phospholipids. Okay, and there's only one type, fortunately. And then we will talk briefly about wax as well as steroids. All right. So those are the 4 kinds of lipids. All right, take a picture, finish copying, whatever you need to do. I'll move on to the next page soon. And for those of you who just joined us, please watch the recording for the part that you missed, because I explained a little bit about what to expect on the quiz next week. All right. So, lipids. What are lipids made up of? Well, surprisingly, just like carbohydrates, they also contain C, H, and O primarily. It's the same 3 things that makes up carbohydrates as it is in lipids. Okay, but of course the way that you connect them is different, which is why the end result is also different. Now, lipids is a little bit special when compared to the other 3 types of macromolecules. For carbohydrates, proteins, and nucleic acid, they are long chains of the same monomer being repeated, right? In the case of polysaccharide, such as starch, is like glucose connected to glucose connected to glucose like many times, right? Okay. Lipids is different in the sense that there is no repeating units. Instead, lipids has a few components. So let's say there's, A, B, and C, right? 3 different components. And you pick and choose the components to build certain things. So let's say we want to build a fat molecule. I would take component A, and then I would take 3 of component B and put them together, then I get the fat. If I want to build phospholipids, I would take 1 of A, maybe 2 of B, and then 1 of C, and then I would get the phospholipids. So it's not the same thing repeated many hundreds and thousands of times like the other 3 kind of macromolecules. For this one, it's just couple components. You pick and choose what you want, and then you put it together, and that's it. Okay, so in that sense, it's not a long chain joined together. All right. All the lipids are hydrophobic. Can someone explain to me what that means? We learned it last class. What does it mean for them to be hydrophobic?
Not mixing with water.
That's right. They do not dissolve in water. They will not mix well with water. So all the lipids that we listed here, they will not be water soluble. So let's begin with, let's talk about the functions. Okay, so in general, lipids are involved in energy storage. Okay? So glycogen and starch, which are carbohydrates, they are for short-term energy storage. Right? If you haven't eaten anything all day yet, now you will be running on your glycogen reserve. Your body will be breaking the glucose from the glycogen and burning them for resources. But let's say you are stranded on an island, right? And you don't have food for like 3 days, 4 days, your glycogen reserve would deplete, right? Then your body would switch to lipid storage. Okay, it would take the energy from the fat that you have stored. So we have these fat cells in the body that is responsible for storing fat. All these white empty space in the middle, that's where the fats are going to be stored. Lipids are also a key component of cell membrane. Cell is what makes up living things, and surrounding the cell is a cell membrane. A major component of that is lipid, different kinds of lipid, as we'll see. They also help form water-resistant barriers. The skin of an apple is water-resistant, okay? Our skin is water-resistant. You go take a bath, like go into the bathtub, you don't soak up all the water, right? Like you're not like a sponge, right? Water don't penetrate through your skin, right? That's because we have a water-resistant barrier that is lipid-based. So let's talk about where to get fat, right? We don't have to deliberately consume fat. Most of our food already has quite a bit of fat in it, all right? When you eat meat, there's going to be fat in it. When you add like salad dressing, that there's going to be a fat in it. There's going to be lipid in it, right? So it's kind of found in all the food sources that we have. You know, if you really feel like consuming like pure fat, right, then there's the butter, and some people, they like to, you know, consume a scoop of oil, right, for various reasons. So there's like flax oil, there is like fish oil, right? Fish oil, sometimes kids would take them because it's good for brain development, right? But generally speaking, like people don't purposely seek out like fatty stuff to consume, right? Like it's like, yeah, you don't have to do it on purpose. That's my point. Sorry. Even healthy food can have some fats in it, right? Like almonds, for example. This is actually that's not almond. That is walnut. Sorry, walnut is quite high in fat content, right? Now we cannot make all the fat that we need in the body. Right? There are these things called fatty acids. You can make them. Okay, there are various types of fatty acids. You can make most of them, but there are some that you just can't make, but you need them for normal bodily functions, right? So we call these essential fatty acids. Okay, you have to consume it. You have to get it through your diet, right? So an example of essential fatty acid is something called omega-3. You probably have heard of it. Right? Omega-3 is not one thing. Okay? Omega-3 is like a bunch of different molecules that satisfy a particular condition, which I'll tell you later. And common omega-3 are like EPA and DHA, right? If you were pregnant before, or if you are pregnant now, your doctor might ask you to take some EPA and DHA as supplements because it's good for the brain development of the baby, right? Okay, while they're still growing in you. So that's omega-3. We can get omega-3 from natural food sources, right? Things like fish, avocado, and certain kind of nuts. They are really rich in omega-3. But some people would like to use supplements instead. What other omega do you know, guys? Besides 3, you must know the other ones, right? No, nobody takes omega here. Patrice?
Omega 369.
Yeah, 369, exactly, right? It's like, you know, the multiplication table, okay? So those are the good ones. Those are the ones that we can't make. We cannot make. That's why we have to consume them, okay? That's why we call them essential fatty acids. All right, let's talk about the first type of lipids in more details, fat. The fancy name, again, for fat is triglyceride. If you do body checks, okay, they would check your cholesterol level in the blood, and they would also check your triglyceride level. Now you know triglyceride is just like, you know, fat. They want to check the fat content in the blood to see if it's, you know, normal or not, right? So how do we build a fat molecule? Okay, you want to pay attention to the components of each of the different types of lipid, right? So for fat, for triglyceride, we need this thing here called glycerol. Sometimes people call the glycerol the whole molecule. Okay, you see HO, right? That's the glycerol molecule. And we need to hook it up with 3 fatty acids. Okay, that's why it's triglyceride. Tri means 3. Tricycle has 3 wheels, right? Triangle has 3 sides. Triglyceride has 3 fatty acids. I don't want you to get into too much detail about the chemistry, but fatty acids are basically long chains of carbon and hydrogens. You see, carbon is connected to hydrogen, and then hydrogen. So it's just a bunch of carbons with hydrogen attached to them. Okay, now this one is relatively short. It only has 5 carbons. Sometimes they could be very long. They could have like 12, 22, right, carbons in it. The long, short the length of the fatty acid doesn't matter. Okay, to make the fat, I just need 1 glycerol and 3 fatty acids. How do I connect them together? By now, you should be sick of hearing me say that word, right? To connect these things together, we need to do dehydration synthesis. Okay, we need to remove a water molecule and connect them together, form a bond to glue them together. So you take an H from the glycerol, you take an OH, and then you take away water, and that forms the first bond. Same thing for here, and you end up removing 3 water molecule. And more importantly, there is your fat. There is your triglyceride. Okay, dehydration synthesis is to make them. And if you want to break down the fat, you would do hydrolysis. Was there a question? Did I hear someone say something? Okay, just my imagination. So what do we need the fat for? Well, I told you already, it's important for storage of energy, and it's important for providing insulation. It's not uncommon to have a little bit of fatty tissue around major organs to keep them warm. That's what insulation means, right? Like especially in Canada, right? Like -40 outside in the winter. You don't want your heart to get too cold. You don't want your liver to freeze up, right? So the fat will serve as a bit of insulation to keep them safe and warm. Now let's remember here, right? Earlier I said triglyceride fat has 2 types, saturated fat and unsaturated fat. Hey, which one is more healthy? If you have to chuck down some fat, huh? Would you rather do saturated or unsaturated? What's the healthier option here, people?
Saturated.
Saturated fat.
Okay, I have 2 people who say saturated. Anyone else? What's the matter? The rest of you don't consume fat in your diet?
Unsaturated.
Unsaturated. Okay, so we have a few people who say unsaturated, some of you say saturated. Okay, great. I love it. I love it when people disagree, right? And then we will learn what the proper answer is. So let's talk about the difference between the 2 things first, okay? The saturated fat and unsaturated fat differs in the kind of fatty acids that it has. All right. Remember, a fat has the glycerol, the whole, right? The glycerol and 3 fatty acids. Glycerol is the same for saturated and unsaturated fat, but the fatty acid tail can be different. In the case of saturated fat, the tail, which is, again, I told you earlier, right? It's carbon connected to a bunch of hydrogen, right? So in the case of saturated fat, the carbons that is in the tail is connected to as many hydrogen as it possibly can. There's literally no room for extra hydrogen. That's why we call it saturated fat, okay? Saturated fatty acid, because it has no more room to put more hydrogen on. It's saturated with hydrogen. In that case, if I have to draw a saturated fat, there's the glycerol, and when it's saturated with hydrogen, the tails is going to be straight like that. Now I'm going to put another saturated fat next to it, and another saturated fat next to it, and I can even put it down here. And you can see because the tail is like straight, they can easily pack between each other, right? They can get really close to each other without, without problem, right? Imagine I asked all of you to line up at the front of the classroom. If you keep your hands straight down, you can stand next to each other very, very tightly, right? No problem, right? So for that reason, saturated fat tends to pack closely, and therefore they are solid at room temperature. Most animal-derived fats are saturated. If it's come from an animal source, it's most likely a saturated fat. Okay, so what is so bad about saturated fat? Okay, that is the answer. Okay, saturated fat is the worst one between the 2. Okay, because if it packs nicely outside of your body, it's also packing nicely inside your body, right? So if you consume a lot of saturated fat, they tend to build up in your blood vessels, right? They makes your blood vessels harden over time, and it could clot your blood vessel. right? So saturated fat, you want to limit them, okay? But every now and then, like, you know, you crave for some buttery stuff, right? Like if you eat pastry, right? Pastry is so fluffy, right? Because of the butter. And to make them even fluffier, some people might use lard, right? Lard is like this like white chunk of basically animal fats, right? And when you use that to make pastry, so good, but it clogs your artery, also so good, right? So you wanna you wanna limit that. All right. So are we together? Do we understand what saturated fat is? All right. Thank you for the thumbs up. Okay, even though I get just one, but I assume all of you are giving me like silent thumbs up. Okay. Now we're gonna talk about. Thank you. Now we're gonna talk about the unsaturated fats. Okay. Unsaturated fat, on the other hand, has at least one of the fatty acid tails that has a double bond in it. Okay. Now you will learn more about double bond in chemistry. I don't want to get too complicated here. So let's go back here, right? The saturated is just a single line connecting the C. Okay, the line represents shared electron. A double bond has like two lines, so they have extra electrons that are being shared. And when that happens, it means there are still room for hydrogen. They are not attached to maximum number of hydrogen. Okay, they are not attached to maximum number of hydrogen. Now, as a result of that, if I draw an unsaturated fat, we have this little oval here to represent the glycerol, the ho. And then we would have, you know, two tails. And then the one with the double bond would create a kink, a bend, okay, a sharp turn in the structure. So when you have another unsaturated fat that wants to get close to it, it can't because the kink is in the way. Right? Think back the analogy. If I ask you guys to line up at the front of the room and you're like sticking your arm out, like just stay away, man. Okay, social distancing, right? Then you cannot get very close. So when the molecules can't get very close, it's gonna be liquid at room temperature, right? They don't tend to pack as closely, right? So they don't tend to build up as easily in your bloodstream, and it's the relatively healthier choice of fat. Most plant-derived fats are unsaturated, okay? Example would be olive oil. That's an unsaturated fat, right? That's what people say. It's like, you know, it's okay. You can pour olive oil onto your salad. It's I wouldn't say it's good for you necessarily, but then it's not like, you know, unhealthy, right? Do you guys cook with other kind of oil that is unsaturated? My morning class gave me like a whole bunch. Anybody have anything here? I don't know. What do you guys cook with?
Coconut oil.
Okay, sunflower oil, olive oil, great. Someone said
Avocado.
coconut oil, right? So actually interesting. Morning class also mentioned coconut oil. See, coconut is a plant, right? Okay. But you know, the coconut oil is it liquid? Whoever's mentioned coconut oil, is it liquid?
Some are liquid. The one I
So-
have is liquid.
The whole thing is liquid? Really?
Yes.
Oh,
In
interesting.
room
Okay.
temperature.
Yeah, but at room temperature, usually the coconut oil is like a white paste, and then they might have a little bit of, you know, liquid portion on the top, right? That's the one I am used to seeing. But maybe you're right. Maybe there are other kinds. So coconut oil actually is saturated fat, even though it's plant derived, right? Okay, so there are a lot of other good ones here. Mustard oil, vegetable oil, canola oil, peanut oil. Basically, if you can pour it, then it's probably an unsaturated fat. Are we together on that?
Yes.
Now, it's kind of weird to, oh, sorry, I'm ahead of myself. So earlier I was telling you about the essential fatty acids, right? These are fatty acids that your body really needs, but then you can't make them, so you have to consume them, right? It's the omega-3, right? The DHA and the EPA. I just want to tell you why it is called omega-3. I'm not going to ask you on the test why, but you know, it's something that I feel like, you know, it's interesting to know, right? So I mentioned to you about the double bond, right? Unsaturated fat has double bond in it. It turns out the position of the first double bond will decide what we call them. So here, this is the first carbon, second carbon, third carbon. You see, that's the double bond. That's the like additional line. So if the first double bond occurs at carbon number 3, we call it omega-3, right? Same thing here. right? Omega-3. So you can see these are very long. It has 20 carbons in them, 22 carbons in them, right? Okay. And you know, omega-6, that means the first double bond happens at carbon number 6. That's all. All right. And this is pills that you can buy. Usually they come in like triplets nowadays, not just 3. Okay. Like you get more bang for your buck, right? You buy same price and you get 369 and you pop it all together, right? And then it's good for your heart and good for brain development. Not so much for like adults. Adults, like you take this, usually is for cardiovascular health, right? For the brain is more for kids, okay? When their brain is still developing. Like despite what you think, like our brains don't really develop too much afterwards anymore, right? After you reach adulthood. Okay, I don't have time to go through this, but I'm just gonna spend like 1 minute talking about it. Grocery is expensive nowadays. Everybody knows that now, okay? But eggs are like crazy expensive these days. Used to be like, you know, regular eggs, a dozen of eggs is like what, 199, I remember, right? And then when they're on sale, it might even be like, you know, 180 egg at Food Basic or something. You can buy a dozen. Nowadays, right, like regular eggs cost as much as, you know, 350 for a dozen. But some people like to pay extra. They want to pay extra to get organic eggs. Okay, so they can go as high as like 750 for 1 dozen. And people buy organic food for different reasons. I'm not saying you shouldn't. You must have your own reason if you do that. But people buy organic eggs because they think, one reason is because they think it's more nutritious. Okay, they think organic eggs might have more omega-3, omega-6, omega-9 in it, and therefore it's worth the extra bucks. Okay, so there is a show called Marketplace on CBC. You might have heard that before. They did an episode where they get eggs from all different places, okay, to all the different brands. They get some from organic farms and so on and so forth. And then they run tests on them to see if they are actually more nutritious. All right, so that's an interesting thing to see if you're wondering, right? So check that out and let me know what you think. Moving on. Here are 2 pictures. Okay, we have a picture here for one type of fat and then another type of fat here. All right, this is A, this is B. Based on what I taught you and based on what you're seeing, can you identify the saturated fat for me in this picture? Okay, I'm gonna give you the poll. All right, which one looks like saturated fat? Okay, thank you for participating. I mean, most of you got it right. This one on the left is the saturated fat, right? And this is the unsaturated fat. You can tell because the unsaturated fat has the kink in it, right? There's the banding right here. All these kink, all these twists and turns is as a result of the double bond, right? Okay, because of these kinks, they don't pack together as easily. They are typically liquid at room temperature. Okay. Now, it's a little bit weird to, let's say in the morning, you want to have some breakfast, you put your bread in the toaster, it comes out, and then you're like, okay, let's go with the healthier choice. I'm not gonna put butter on it because it's, you know, it's saturated fat. But it's kind of weird to like pour, you know, canola oil or avocado oil on your toast, right? Like it's gonna get all like soggy and like it just doesn't make sense to do that, right? So people came up with this idea. You know what? Let's start with the vegetable oil. Let's start with the unsaturated fat, and you know, we will use a chemical process to add some hydrogens to it, okay? And change it into a semi-solid. And that's what they did, right? This is called hydrogenation. And the process creates hydrogenated vegetable oil, okay? And example of that would be like margarine and shortening. Right? You know the slogan, right? That says, "I can't believe it's not butter," right? Okay, so yeah, it's not butter because it's hydrogenated. It's hydrogenated oil, basically. Right? So you know it's not the greatest because in the process it actually generates some trans fat as a byproduct. And trans fat is like the worst fat of all fats. Okay, your body does not have the enzyme, doesn't have the chemical to help break down the trans fat. And as such, if you consume trans fat, it will just stay in your body for a very long time. And it's linked to increased risk of heart diseases and diabetes. Okay, so it used to be that trans fat is very ubiquitous, like it's like everywhere. Okay, especially like fast food, there's a lot of trans fat in it because it actually makes the food taste better. And even in like a lot of products that you buy in supermarket, they contain trans fat because they extend the shelf life. Okay, but then recent study highlighted the link between trans fat and heart diseases and diabetes, and so Canada officially banned trans fat in 2018. Okay, so no trans fat anymore allowed for the fast food and on things that you buy. All right, so when you buy margarine nowadays, they actually have to go through the extra process of removing the trans fat in the process to ensure that it complies with the food safety, right, and with the ban. That's it for triglyceride. That's it for fat. Now we're going to move on to the second type of lipids. We have 4 types, right? 1 down, 3 to go. The next one is called phospholipids. Okay, so how do we build a phospholipid? Okay, what components do we need? We need 1 glycerol, the whole molecule. Hopefully you recognize that by now. Plus, this time we only need 2 fatty acids. 2 fatty acids. And we also need to have a phosphate head. All right. So a majority of the lipid are composed of primarily CH and O. Okay? But for phospholipid, there is a little bit of phosphate in it as well because of this phosphate head. Now, the phospholipid is a special molecule because it has 2 very opposing parts. Okay, so usually we draw phospholipid like this. Okay, the tail could be straight or it could be kink like that. It doesn't really matter. We'll explain the difference later on. Okay, but for now it doesn't really matter. What matters though is the head, which is the circle, is made up of the phosphate group. Okay, and that is hydrophilic. Okay, so it has a hydrophilic head, which means it binds well with water, right? And down here, you have the hydrophobic tails, which means it doesn't interact well with water. Okay, so a molecule like this that has 2 different properties are very useful for various things. For example, when you wash your dishes, okay, if it's greasy, you can't just wash it with water, right? Okay, like it's not gonna clean the grease off, right? So you need to add detergent. Detergent is a molecule that is similar to a phospholipid. It has a hydrophilic part, which binds to the water, and it has a hydrophobic part, which binds to the grease. So when you add the detergent to the greasy dish and wash it with water, the detergent basically allows the grease to get pulled off along with the water. Okay, so it's like it's a binding agent, right? The correct word is like it's an emulsifier. Okay, so in the body, the phospholipid also has similar property, and what it does is that it will arrange itself like this. All right, so this is a cell, okay, and then we are zooming into the cell membrane. The boundary around the cell is called a cell membrane, right? So if you look at that, then you will see there is the hydrophilic head facing the outside of the cell, which is primarily water, and the inside of the cell is also water. But sandwiched between the 2 layers of hydrophilic head would be the hydrophobic tail. So that creates a barrier to help regulate what goes in and what comes out of the cell, right? Things can't just go in and out on their own without regulation, right? It's not good for the proper functioning of the cell, right? So we will learn more about the cell membrane in lecture 4, I think. wax. Don't worry too much about wax. I'm just going to spend like literally one slide on it. I don't think there's any question on the test about wax. Wax forms these water repelling surfaces, right? That's why in the morning, the morning dew, you see the water droplets on the leaf or something, right? Because the leaf has a coat of waxy barrier. Other example of wax would be like beeswax. Some people use beeswax for cosmetics, okay? Lip balm, for example, and other stuff. And our skin, our hair, they are lubricated with waxy substance to give them a water repelling surface and to give them like the shine, right, the sheen, right, that you see on healthy looking hair. That's it. That's all you have to know about wax. Okay. Last but not least, we have the steroids. Okay, steroids. Now, when people hear the word steroids, when you hear the word steroid, what is the first thing that pops into your mind? Let's hear it. What's the first thing that comes into your mind? If it's inappropriate, don't tell me, okay? But otherwise, let me know. Okay, gym people, yeah, big muscle, right? Okay, like that's what people think about, right? Steroids, doping, taking steroids cause you to become strong and big, right? But actually, we have naturally occurring steroids in the body, and they're essential for regular bodily functions. Okay. So the component that makes up steroids include 4 fused carbon rings. Okay, so each of these hexagon represent a carbon ring. So that's 1 ring here, 2 rings, 3 rings, 4 rings. And attached to the rings are these functional groups. Okay, so functional groups are like things that are attached to the rings. Okay, you don't have to know what they are called. You don't have to know what they do. You will learn that in 2nd semester chemistry. But functional group basically give the steroid unique properties. Okay, think of them as like, accessory for your laptop or accessory for your phone. Okay, like you can add a case to it, right? You can add a lanyard to it. You can add those bling bling things on it to make it sparkly, right? You can add whatever you want. You can customize it to make it unique, to make it, have different properties, right? So that's what the functional group does. All right, it attaches to the core ring structure, and it gives the steroid a unique structure. So here, this thing that you see here, it's cholesterol. Right? And again, when people hear the word cholesterol, they're like, oh, unhealthy. My doctor said I should keep my cholesterol down. But actually, there are good cholesterol and bad cholesterol. Okay, and it turns out cholesterol serve many normal functions within the body. One of which is that it also helps form the cell membrane. Remember the other component of cell membrane, right? The phospholipids. That's the major component. Okay, I would say like 85% of it is phospholipids, but then you would have a little bit of cholesterol as well. Okay, we'll learn what it does later on. But we also need cholesterol as a raw material, as a starting material to make other things. Okay, they make things like a bile salts. Does anybody know where bile is from in the body? Where do you find bile? What organ, huh? Gallbladder, excellent. Okay, so you have a little pouch looking thing that is attached to your liver, and the liver makes bile, and then you store it in the gallbladder. And when you need it for digestion, your gallbladder squeezes it out. Okay, so you need bile to digest lipids. For those of you who may be not familiar with what I'm talking about, maybe you were food poisoned one time in your life, and then you vomit a lot. Okay, you vomit, all the food comes out. Oh, you feel terrible, but then you still want to vomit more. Okay, when you vomit everything out and there's nothing else to vomit, and then you still want to vomit, the next thing that comes out is going to be the bile. Okay, it's gonna be the bile. You will know you are vomiting bile because it is extremely bitter and it's greenish in color. All right. I don't know if this is a relatable story. Usually a few people had that experience in the class. Okay, not a pleasant one, but now you know what bile is. I had a student who said back home he works in the family business, which is like a butcher shop. And one of the first thing that they taught him when he was really little is to be careful when handling the meat. You know, when you try to cut the cow or whatever, like you got to be careful not to rupture the gallbladder. Because if the gallbladder is ruptured, all the bile comes out, you cannot sell the meat anymore. Everything is bitter. Okay. Anyway, I went on a tangent. That's what a biosol is. You also need cholesterol to make things like vitamin D. Okay, of course, you need to stay in the sun to make that as well. And steroid hormones. Okay, now I want to tell you a little bit more about hormones. You will hear me come back to this again later. Okay, hormones are chemical messengers in the body. Right? It helps one part of the body to communicate with another part of the body. All right. So like the brain can secrete hormones and then it could tell your, thyroid gland to do something. Right? So it's chemical messenger. Hormones can be lipid-based hormone. That means they're made up of lipids, or they could be protein-based hormone. Okay. So right now we're just looking at lipid hormone. The common liquid hormone is the sex hormone. Okay, that's one example of it. Right? So in male, testosterone is steroid hormone. For female, estrogen. And what's the other one that's not on the slide? What's the other female sex hormone?
Progesterone.
That's right, progesterone, right? So both of them are steroid. How do you know I'm looking at a steroid? Well, you see the rings, don't you? 1 ring, 2 ring, 3 ring, 4 rings. And then we have these, functional groups on them, right? This one also has 4 rings, 1, 2, 3, 4. And then, different functional groups on them as well. Okay, so that's it. So steroid is not just for doping. You have natural steroids in your body. If you have a bit of acne, the acne cream that you put on also contains steroids. Okay, if you have those cream at home, look at it. Right? It's called cortisone. Okay, and it has anti-inflammatory properties. All right, I talk so much. Let's pause for a second and let you try this question. Okay, hopefully you finish reading. I am going to launch the poll. All right, couple more seconds. Most of you got it right. The correct answer is the triglyceride, right? Okay, tri means three fatty acids. Okay. Which of the following is false about lipids? Okay, just one correct answer. I'll let you read it first. Okay. We have two popular choices here, A and D. Let's take a look at them. First one, oops. Steroid has at least one fatty acid tail. That actually is not true. That's the false one. Okay, look at the steroids here, right? Do you see a fatty acid tail? Do you see a fatty acid tail? No, right? Okay, it's not essential. The only thing that's essential for a steroid is that it must have like 4 carbon rings, right? That's the only thing. D. A lot of people chose D. Cholesterol is a steroid. What's going on, guys? What's going on? Look here. All right, it literally says steroid is cholesterol. Okay, steroid is cholesterol, right? Okay, so that is a correct statement. All right. That's it for the lipids now. I think I'm gonna take an early break. Let you guys take an early break. Because I don't want to talk for a few slides and then stop. Protein is the hardest one. All right, so you need to pay like extra attention for it. So let's go for a break. We'll resume in 5 minutes. That would be 1:32. All right, see you in a bit. And we are back for more macromolecules. So we did the carbohydrates, we did the lipids, and now it's time for proteins. All right. Like I said, this is the most complicated one. So please make sure you pay extra attention and do stop me if I am talking too fast or if I'm not making sense at all. So proteins. What are proteins made up of? Well, you see the triplet here again, the C, the H, and the O. Essentially, all of the macromolecules has carbon, hydrogen, and oxygen in them. But in the case of protein, there is also nitrogen. All right. And trace of sulfur. Trace means a little bit. Okay. And you will see where that comes from later. The monomer of protein is amino acid. Okay, amino acids, and it's much more than carbohydrates. Right? Remember, in carbohydrates we only have 3 monomers, right? Glucose, galactose, and fructose. But for proteins, there are a total of 20 amino acids. You don't have to memorize all of them. All right, you just have to know there are 20 of them. Of the 20 amino acids, 9 of them are essential. Right? We saw this word before, right? In fatty acids, right? Essential means you cannot make them in the body, but you need them. So where do you get them? You have to eat them, okay, from your diet. Now, unless you are like a picky eater, the regular meal that you eat should include all the essential amino acid already. You don't have to get out of your way to get certain kind of essential amino acids. Okay, but if you wanted to, this is a chart that shows you where certain food would be very high in a particular amino acid. So there's something called histidine. You can get them from like rice, wheat, potato, right? Threonine, you can get them from like watercress. I don't even know what that is. Pumpkin, chia seed. Right? So different kind of food may be richer in a particular kind of amino acid. But like I said, unless you're like avoiding a lot of foods, generally speaking, a typical meal would give you good coverage of these essential amino acid. Now, there is a particular one here called phenylalanine. All right. And to metabolize, or metabolize just mean to like break down, right? To break down phenylalanine, we need to have an enzyme to do that. You hear me say the word enzyme a lot, right? Here, I write the word enzyme, E-N-Z-Y-M-E. We'll learn more about it later. But basically, any reaction that happens in the body, you will need to have an enzyme for it, okay? So there are some people who are born with a rare genetic condition called PKU, which stands for phenylketonuria, okay, or just PKU for short. And they don't have the enzyme to break down, to metabolize the phenylalanine. And the phenylalanine can build up in the body and start accumulating in the brain and interfere with brain development. Okay? So, if the baby is born with PKU and you don't know about it, and you try to feed them breast milk or regular formula, they would have PKU in those things, right? In the breast milk and the formula, and the baby would not be able to break it down, and then they would have brain damage, right? So one of the first things they test in newborn, like almost like right away as soon as they're born, is to see if they have PKU. Right? So it's a simple blood test. They can do a heel prick. It's called heel prick. You prick the heel. Okay, you make a little cut in the tiny foot here, and then you test the blood for it. Okay, and if finds out that they have the PKU, then they have to go on a special diet. Okay, they have to go on PKU formula. Okay, specifically designed so that it doesn't have phenylalanine for it in it. Does that make sense? Right. So, if you have a baby, your baby probably got tested for this thing when they were born. All right. Now this looks very complicated. This picture here. Don't get intimidated by it. Okay. Just hear me out, and I'll try to explain it the best I could. So, this is the general structure of. Sorry, I'm trying to choose the right color. Okay, this is general structure of an amino acid. Okay, how many amino acids did I say there are in total? Okay, hopefully you have
20.
20, that's right, 20. Okay, 20. All 20 of them share a similar structure like this one. Okay, so there is this thing here on one side called the amino group. Okay, there is the other thing on the other side that is called the carboxyl group. I know it's a lot of names, okay, carboxyl group. And that's what I mean, right? Like if you need to put this on that help sheet of yours for the quiz, that's okay. Do it, okay? In fact, like don't write a quiz with no A. I would strongly suggest you make some kind of help sheet. Okay, there is a central carbon. Now I'm only speaking for my course, okay? Like don't go around telling your other prof, oh, Vincent, tell us we can cheat, okay? It's not cheating, okay? For my course, I give you permission to use the notes, okay? What other teacher does is their thing, okay? I want nothing to do with it. Okay, so this is the central carbon. Okay, and then there's like a hydrogen. Okay, so all amino acid has these features to it. Okay, what makes them different is the R group here. I don't have an orange here, unfortunately. Oh, I do. Okay, so this R group, that's called a side chain. Side chain. Okay, so this is unique for each amino acid. All right, it gives them different properties. Right? It makes them different from each other. Now I'm gonna show you a picture here. Okay, I'll come back to this if you need to copy it. But first, over here, right? This is all the amino acid there are, 20 of them, right? You can see. Right. So all of them has the core structure that I was trying to show you, right? Look, right? The central carbon, the amino group, the carboxyl group. And what makes them different from each other is the R group, right? Okay, you see they all look different. This one has a H, this one has a CH, right? So on and so forth. This one has the S, the sulfur, right? That's why it's trace of sulfur, and so on and so forth. So depending on what the side chain is, they would have different properties. Some are non-polar, some are polar, some are charged, positive charge, negative charge, right? It gives them different property. That's all. All right. Now I want to show you this next thing. You don't have to copy it. Okay, you can just watch. I will never ask you to draw this on a test. Okay, I just want to show you what it looks like so you have a good understanding. All right, this is in your study guide. If you have the study guide with you, you can turn to it with me, or you can just watch. All right, if you want to watch this again later, it would be in the I say like around 1 hour mark, 1 hour 10-minute mark of the video. Okay, so here we go. This is one amino acid. This is another amino acid, right? And we want to connect them together, right? So please tell me, what is the name of the process that we use to connect things together? You should know this by now. I'd be heartbroken if you don't. Okay, hydration, okay. Dehydration, yeah, you're missing the key prefix there. Yeah, that's okay. Yeah, dehydration reaction, right? Dehydration synthesis. What does it mean? To dehydrate is to remove water molecule. So how do we do that? Well, we are going to remove an OH from the carboxyl group. Okay, I'm gonna write here. Remove OH from carboxyl group. Right, we just say carboxyl, okay? And we're gonna remove H and H from, what's this thing called? Well, if you roll it down, you should have it in your notes, the amino group, right? Okay, so you see, if you take the OH and the H and you remove it, you have a water molecule that comes out. And then you can create a bond that connects them together. Okay, this bond is called a peptide bond. Peptide bond. Okay, so now we have a dipeptide. It's the same theme, right? Like before, we take the monosaccharides and we connect them, then you get the disaccharide. Now we get the dipeptide. Okay, but I want to take this one step further. Okay, I want to draw the peptide backbone to show you. All right. Now this is very difficult to follow, to draw with me. Okay, like so, like you don't have to. You can just watch me do it. I will post the answer to the study guide, and you will have a nice drawing for it anyway. Just try to watch and understand what's going on. All right. So this is one amino acid, right? With a side chain. Okay, I don't know what it is. I'm just gonna call it side chain number 1. C double bond O and OH. Okay, that's amino acid number 1. Okay, I hope you are following, that you understand what this means. Now I'm gonna do a second one here. Okay, I'm gonna do a second one, and I'm gonna draw it really close. Okay, so this is R number 2. Okay, so like you see, this is the first amino acid. This is the second amino acid, right? I'm gonna draw a third amino acid. Third amino acid. Okay, and since this is so much fun, I will draw one more. Now, in reality, if you want to build a protein, it would have like many amino acids, right? It could have like hundreds and sometimes thousands of amino acids, right? Okay, and so I'm gonna stop here. So how do we connect them? Now, watch. We will remove the OH from the carboxyl group. We will remove the H from the amino group, and then we'll have an H2O that comes out, right? I'm not gonna draw it because I don't want to confuse you, but then I can connect them. That's a peptide bond, yes? Then I go here and we do it all over again. Remove the OH, remove the H, make a connection. Move on. Remove the OH, remove the H, make a connection. Okay? So you see, after you connect many of them together, even hundreds of them together, right? What do you see? the backbone is not changing. I'll read it to you. Look, it's going to be NCHCO, 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 and it just keeps on repeating itself, right? So this whole thing right here, right? Oh boy, wrong thing. 1 second. Wait, was that right? Is that highlighter? No, that was not highlighter. This is highlighter. Okay. So this whole thing that I'm highlighting, that is the backbone. Okay, that is the backbone. Okay, that's okay, Kristen. Thank you for letting me know. Okay, just watch the recording later if you need to. So that is the backbone. Okay, and it's the same thing for the entire peptide. All right. So you will see this. You will see it drawn like this. Okay, like you would have the whole polypeptide, the backbone, and then you would have like R1, R2, R3, R4, so on and so forth, right? The side chains would be different, but the peptide backbone would be the same thing. Do you understand? Okay, it's not important for you to draw this out, okay? Like I'm never gonna ask you that, but I want to show you this so that it makes it easier for you to understand what I'm gonna teach you next. Okay, so this is just to show you the different amino acid once again, right? In a slightly different way, and some of them are acidic, some of them are basic. It depends on the side chain, right? And this shows you like a professional drawing, right? Of how you remove the OH from the carboxyl group, remove the H from the amino group, and then you form a peptide bond, right? This thing right here in the center, in the middle, that connects the C and the H, that is your peptide bond. Okay, right here, peptide bond. Next, we're gonna spend some time to talk about the 4 levels of protein structure. All right, you will see that. I'll tell you later in more detail, but the shape of the protein is related to its function. If you change the shape of the protein, its function will be altered, or it will not be functional anymore. Okay, so how the protein folds up, it depends on each of these levels. Okay, primary, secondary, tertiary, and sometimes they would have quaternary as well. So let's learn about primary. The primary structure is referring to the unique amino acid sequence in the chain. All these circles, each of these circles represent an amino acid. So when your body makes a protein, it will it will choose the amino acid to use. We have 20 of them, right? So which one do we connect together, right? Maybe you take the, valine connected to phenylalanine, and then histidine, and so on and so forth, right? So the sequence from one end to the other, that unique sequence, that's called a primary structure. What determines the sequence of the protein? Well, it is your DNA. Right? So your DNA, your genetic code, contains the instruction to make the proteins. Okay? Later on in the course, I will show you how to decode the DNA to figure out what amino acid to use. Okay, that's lecture 7. So imagine having a set of beads, right? Like different color beads, and you want to make a necklace. Right? So like you might get the red one, the orange, green, purple, blue, orange, red, blue, right? Whatever the sequence, right? The order that you link them together, that would be like the primary sequence. Okay? Since it is determined by your DNA, if you change the DNA, right, we call that a mutation, that could end up changing your protein. Okay? And it could have undesirable consequences. More on that later. But that's the primary structure. Now we're going to go into secondary structure. Now I have a pipe cleaner here. All right, so let's say the sequence, right? From one end to the other, that's the primary sequence. Now, the next thing that's going to happen is once you connected all the amino acid together, this strand, it might coil up like this. Okay, so it will form a little, where's my camera? Right here. Okay, it will form a little coil. Okay, and then some other part, it might form like a zigzag. You see that? Like this zigzag, like this. So zigzag here, okay, which is flat, right? Look, it's flat. I don't know if you can see it. This is zigzag, and then the coil is kind of 3D, right? You see the difference? Okay, I hope you do. All right, my very low budget prop here. Okay, so whether it forms the coil or the zigzag, that's the secondary structure. All right, the protein can have only coils, that's fine. It might have only zigzag, that's also fine. Or it might have some combination of both. All right. So we call the coils, we call them alpha helix. Alpha helix. And the zigzag, we call them beta pleated sheets. Okay? And what holds them together is the hydrogen bond that is formed with a backbone. Remember the yellow thing that I highlight, right? The backbone, right? That is that is going to have some hydrogen bonds in it. We already learned about hydrogen bond before, right? From water molecule, and hydrogen bond can exist in the backbone of a protein as well, and that will help them, stabilize these alpha helix or beta sheets. Okay, so in this picture, the arrows represent the pleated sheets, and then the coil represents the alpha helix. Okay, so primary structure is just the sequence, and then secondary structure is whether they form coil, the alpha helix, or the parallel beta pleated sheets. Do we have any question? No? Okay. Sorry, just give me a second. Just have to reply a quick email. All right. So you might be thinking, who cares? Like alpha helix, beta pleated sheets, why do I have to know this, right? Is there like any real life implication that's relatable? Yeah, there are a lot of real life implications, but let me just show you one that you might be interested in. Okay, mad cow disease. Does anybody know what mad cow disease is? How do you get it? What is it caused by? Is it caused by bacteria or virus? Anybody know? Wait, have you guys heard of mad cow disease? Anyone at all?
No.
No? Okay, some of you, yes. Okay, so is it caused by bacteria or virus? Anybody know?
I want to say virus.
Virus, yeah, okay. Nimio caught my trick question. Yeah, it's a trick question. It's actually not caused by virus, and it's not caused by bacteria. In fact, it's not caused by anything that's alive. That is really weird, right? Okay, it's actually caused by a protein called prions. Okay, prions. Now, what that means is you can cook the beef, the contaminated beef. Well, I mean, like it shouldn't be a surprise that you would catch it from cows, right? Like eating contaminated beef, right? Because the name suggests to you, right? I mean, you can catch it from other sources as well. But you can catch it from cows that are contaminated by eating the contaminated meat, and you can cook it all the way to 100%, fully cooked, okay? And it wouldn't matter. It wouldn't. You would still, get sick from it. Because it's not bacteria, it's not virus that's causing the problem. Okay, it's caused by something called prions. And prion is a protein that we all have, okay? So the normal version of this protein, the prion, looks like this, okay? It has the ribbons in it, right? The coils, right? So this one has the alpha helix. That's It doesn't have any of the beta sheets. It only has alpha helix. For the prions that are found in cows that have mad cow disease, theirs is misfolded, okay? So they have the beta sheets. I'm just gonna call it beta sheets for short. All right, so let me set the stage for you one more time. We all have prion proteins. This is the normal one, okay? And it's alpha helix. The diseased one is misfolded and it has the beta sheets, okay? So in healthy people, you will not have this one on the right, okay? And what happens is, let's say you eat contaminated beef, okay? That has the mad cow prions in it. What happens is now you would have the misfolded protein in your system, right? Okay, so this is the normal protein. This is the misfolded protein. Like a bad friend that has bad influence, it will come and then it would, cause the good protein to misfold, and now you have two misfolded proteins. Both of these are now beta sheets, okay? And then they will go find two other good proteins and then cause them to change. And before you know it, all or most of your normal prion proteins will change and misfold into the beta sheeted form. And they tend to clump together and cause neurons to die. And that's how mad cow disease is lethal, okay? It will leave holes in your brain. This is from the brain of someone who died from mad cow disease. You can see all these holes. It's not supposed to be there, right? And mad cow disease is called spongiform encephalitis. Okay, spongiform means it looks like a sponge full of holes. Encephalitis means inflammation of the brain. Okay, so that is not a good way to go. Okay, but that's one example of how studying these alpha sheets and beta sheets are important. And now moving on. Tertiary structure. All right, so look, I got my lovely pipe cleaner here. We got the alpha helix, we got a beta sheets. What is the tertiary structure? Okay, tertiary structure means the protein now is gonna fold up. Okay, it might fold up onto itself, and then it become like a ball, maybe. Okay, like a ball. So it has like 3-dimensional shape. All right, the 3D shape, the overall 3D shape, that is called the tertiary structure. Okay, everything else before is kind of 2D, it's flat. But now it folds up, it becomes a ball. Oops, becomes a ball, okay? That is the tertiary structure. And what's holding the tertiary structure together is the interaction between the R groups. Remember the R groups, right? Like you got the yellow ribbon that represent the backbone, and then you have the R1, R2, R3, R4, all these different side chains. Well, they can interact with each other to help stabilize, to help support the 3-dimensional shape. Okay, you do not have to memorize these interactions, okay, but you should know that the interaction of the side chain will stabilize the tertiary structure. Okay, so you might have some hydrophobic parts coming together, you might have some ionic bond and hydrogen bond and whatnot. Okay, so that forms the tertiary structure. And most protein would stop here. Okay, they form their 3D shape and that's it. Right? We have a fully We have a fully functional protein that's going to go on and do its thing. All right, but sometimes you would need to go up another level. Okay, you're going to have to go on to the quaternary level, which means this one here is not. I mean, it's a protein on its own, but it cannot do its job. It needs to have another protein, and they will come together and form one unit, okay? A complex, we call it. Maybe you need a third one and a fourth one, right? Like in this picture, you have 4 different things coming together, right? So, what peptides we need to bring together to form a functional complex, that is called the quaternary structure. Okay, and again, not all proteins need to have a quaternary structure. Many are fully functional at the 3rd level, but some will need to go on to the quaternary structure. All right, so an example of this would be hemoglobin. Hemoglobin is a protein that is found in your red blood cells, and it helps you carry oxygen. Okay, and hemoglobin has 4 peptides to it. Okay, 4 peptides for it. That's it. That's the 4 levels. Before I move on, any burning questions that you might have? Doesn't have to be about protein. Could be about anything that we've learned so far. Okay, any concerns, suggestions, what
Yes.
have you? Yeah, go ahead.
Sorry. About the alpha helix and the B sheets, right?
Yeah.
The alpha helix, that's the one with the coil,
Yes.
correct?
Yeah.
And then the B sheets is the zigzag one.
That's right. Absolutely.
Okay, so the one that's corrupted, like in the example with the mad cow, that's the zigzag, the B sheets.
Okay, I just want good question. I just want to clarify. Okay, beta sheets itself is not a bad thing. Okay, and alpha by itself is not a good thing. They are an integral part of any protein. Okay, if you look at any protein structure, you might find alpha sheets in it. Alpha helix in it or beta sheets in it. But in the example of prions in mad cow disease, it turns out the bad one has a lot of beta sheets in it. That's all I mean. Okay, so don't think of beta as bad in general. It's only bad in the context of mad cow disease. Does that answer your question?
Yes.
Okay, that's
I just wanted to differentiate the two for myself. So yeah.
Yep, no problem.
Thank
That's
you.
a good question. I'm sure other people are confused as well. Anything else? You guys are so quiet. What's going on? Is it like because it's after lunch? You get like, did your morning math class tire you out or something? Anything else?
We're overwhelmed with the mad cow disease.
Okay, perhaps. All right. Well, if you think of anything else, please just ask. Okay, you guys are making my job easy. Like I don't even have to answer questions. I just talk. Yeah. Anyway, maybe that's a good thing. Moving on. Next part. The importance of protein structure. Right? I told you, the structure of the protein is important for what it does. If you change the shape, it will no longer work, or it will work in an unpredictable way, in a different way. Okay, so the shape of the protein, the fancy word for it is conformation. Conformation. Okay, that's the overall 3-dimensional shape of a protein. Think of it as a key and lock relationship, okay? Each key has a unique shape and it fits a particular lock. If you bend the key, if you file the key, right, make the groove a little bit deeper or shallower or whatever the case, it will no longer fit the lock. It will lose its function, right? So key and lock relationship. So what factors would change the shape of the protein? Well, we do this on an everyday basis. Okay, when you are cooking, you are basically denaturing the protein. Denature means to unfold the protein, right? Okay, think of an egg. Right? Many people actually don't know this. I was surprised. Like if I ask this during a class and I ask people to tell me whether the protein is in the white or the yolk, right, or both, right? Many people get it wrong. Hopefully you know, right? The protein is in the white part. All right. So when you cook the egg, it goes from transparent to white, right? That's an indication that the protein has been denatured. It has been unfolded, and it's an irreversible process. Okay, you cannot uncook an egg, right? Okay, once it's denatured, it's denatured. Right? That's why, prolonged fevers in the body is dangerous. Right? By heating up the body too much, it might cause some of the sensitive proteins to denature in the body, and then we're going to be in trouble, right? Other factors, like cooking meats, is the same thing. It's the same thing, right? When the meat changes color, that's like a sign of denaturation, right? Opposite can be true, right? When you freeze something, right, it could cause it to denature as well. Can you think of an example of like a dessert that you make? Okay, kids love this kind of dessert, I guess, and you can make it at home. and it requires putting it in the fridge, and then it, okay, yeah, some of you already get it, right? Like, I'm trying to describe Jello, right? Okay, Jello is protein, gelatin, right? Like if you want to make a mousse cake or something, you need to add those sheets of gelatin to make it, into solid form, right? That's protein, right? So, cooling it could cause it to become denature as well. All right. Other factors that could denature proteins include like pH, salt concentration, right? Type of solution, right? That's why last class I told you the narrow range of compatible pH in the blood is very, very, very narrow, right? If you go too high or too low, it will cause some of the blood protein to denature, and then they no longer work, and we can be in trouble. So here is again like a real life medical scenario where the misfolding of the protein caused problem. This is a normal red blood cell. Inside the red blood cell is the hemoglobin that I told you about. Okay, so normal hemoglobin, it has 146 amino acids. Okay, and here are the first 7. Okay, like valine, histidine, leucine, threonine, proline, glutamic acid, glutamic acid. All right, that's the normal sequence. And how does your body know how to make it? Well, the instruction is in your DNA, right? So some people are born with a mutation. A mutation is a permanent change in your DNA. And so for those individual, because the mutation, the change happened in the DNA, that means the instruction to make the hemoglobin is altered, right? So when the cell try to make the hemoglobin, it will make a mistake at amino acid number 6. So instead of a glutamic acid, now you have something called valine, okay? So the properties of glutamic acid and valine are so different that it will cause the protein to misfold. So you can see here, right? Valine is over here, which is nonpolar, and then glutamic acid is right here, which is charged, right? This is like completely different property. All right, so when you do that, it's going to cause the hemoglobin to misfold. And when the hemoglobin misfold, it will change the shape of your red blood cell. Okay, normal red blood cell is like Tim Horton used to have these jelly-filled donuts. They don't make them anymore, but they're like, big circle ones. And then there's no hole in the middle, right? The whole thing is like covered with like powdered white sugar. I don't know if you know what I'm talking about, okay? It's like one of those jelly-filled donut, and then you pinch it in the center, then you get your red cell, okay? The sickle cell, red blood cell, is moon shaped, and then they get caught in blood vessels very easily, and they get destroyed, and you won't be able to transport oxygen efficiently. So in this case, people get sickle cell anemia. Okay, sickle cell anemia. There are different causes of anemia, but generally, if a person is anemic, they would have trouble transporting oxygen, and they would feel shortness of breath, right? They would be tired. And sickle cell anemia can be quite painful as well, because the cell gets stuck in the capillaries, and then it kind of blocks the circulation a little bit, so the patient would experience some pain associated with that. All right, so this is an example where you change just a single one out of 146 and totally mess up the whole red cell and cause quite a bit of problem. So what else does protein do, right? Okay, so protein forms a lot of the structures that we see in living things. Muscle is mostly protein. There are two main proteins in muscle. Okay, you learn that next semester. It's called actin and myosin. Your fingernails are made of proteins, right? So like if your fingernails, like it's very brittle, like your hair is like, falling off or something, that's a sign of like not having enough proteins. Okay, and it could be various reasons. Malnutrition is one possible cause. When you are stressed out, your body starts to break down protein as well, right? So like you might lose hair as a result of stress. Horns is made up of proteins. Yeah, I just like I was my kids was watching this show the other day, and they were saying, there are these poachers who would like hunt down rhinos or something, right? And then they would cut off their horn, I guess. And then some people believe, if you grind the horn into powder, it has like medicinal properties, right? Okay. And then that leads to like overhunting of like rhinos, right? But as the show was saying, right, like scientifically speaking, the stuff that makes up the horn is exactly the same stuff that makes up our nails. Okay, it's the same kind of protein. Okay, like would you grind your fingernails into powder and drink it like that? Like no, right? Okay, so they're saying it's like there's this misinformation about medicinal property that doesn't exist. Okay, so if you understand it's the same kind of protein, maybe you will save the rhino population. Spider web is also made of proteins. Okay, did you know they engineered a very special kind of spider web? They modify the spider because it's protein, right? And protein, again, the instruction is from DNA. We have the technology to change the DNA at will nowadays. Okay, so like if you change the property of change the DNA coding, you can change the property of the spider web. And you can look this up. They actually cause, I think it was sheep, to make a special kind of spider web in the milk, and then they extract the spider web and they make like a bulletproof vest from sheep. I said sheep. I know, right? Hard to believe. Yeah. So the milk of the sheep would produce this special kind of spider web, and then they use it to make like a bulletproof vest. Right, vest, right? Just as like a proof of concept, right? So they engineer this super strong spider web that has these very tensile property. It sounds like science fiction, but I kid you not, it actually did happen. All right, so you can look it up. Anyways, I went on a tangent again. Other functions of proteins include, forming hormones. I was telling you earlier, hormones can be steroid hormones, like the sex hormone, right? The estrogen, progesterone. But there are protein hormones as well. Right? You probably have heard of insulin. Insulin is needed for absorbing blood sugar, okay? And that's a protein hormone. We also use protein as energy source. Right? We prefer carbohydrates, but we can metabolize protein as well. And then it forms enzymes, right? I've been telling you about enzymes for a couple of class now, right? Talk about enzymes to break down lactose, otherwise you're lactose intolerant. We talk about needing an enzyme to break down phenylalanine, right? Otherwise you might have PKU. So what exactly is enzyme? Okay, so enzymes are proteins and they help catalyze or speed up chemical reactions in the body. Okay, don't worry too much about the graph. Okay, let me try to simplify for you. You have some reactants, some ingredients, okay, and you want to turn it into something else. Okay, so an example would be like this. Let's say we have glucose, okay, plus galactose, and then that will form lactose, right? Okay, this is a reaction. So this would be the ingredient, that's the reactant, and then the product would be the lactose. So for this reaction to happen, you need to supply a little bit of energy. Right? The energy that you need to supply is called activation energy. So you can see the blue graph here. You need a lot of activation energy. Okay, it's not possible to do this reaction in the body if we have to supply this much energy. Okay, your body cannot afford to supply that much energy. And that's where enzyme comes in. Enzyme will help you lower the requirement, okay, so that now you can carry it the same reaction without paying so much energy. Think of it as like scholarship, okay? If you want to go into certain programs in the university, okay, maybe, or college, maybe it costs like, I don't know, $10,000. So expensive, people cannot afford it. But with the help of a scholarship, with the help of an enzyme, it lowers the requirement. It will pay for some of it, okay? So instead of paying $10,000, instead of paying 10,000 units of energy, you only have to pay 7,000 or something. Does it make sense? Right? So enzyme helps you lower the energy requirement for reactions so that they can happen in the body. Otherwise, it would take too long. Otherwise, it would never happen in the body. All the reactions in the body would need to have an enzyme. Okay. 2 more slides and then I'll let you go. This illustrates how an enzyme works. Okay, so the blue thing here is an enzyme. It's made of proteins. Okay, please remember that it's made of proteins. Now there is a slot here called the active site. The active site is where things fit into a slot. Okay, there's a special spot for it. Okay, so let's say, using our example, right? This is like glucose. This is galactose, right? Okay. So these things would have to fit into the slot. Now the enzyme is only designed to work on certain things. Okay, that's why the shape is important. This is a protein, right? If you change the shape of the active site, the glucose might not fit anymore. Okay, it's a key and lock relationship. The thing that fits into the active site is called the substrate. Okay, this is the thing that goes into the slot, into the active site. Okay, so the active site is the slot to put things in, and the thing that goes into the slot is the substrate. Okay, so in this example, we have the glucose and the galactose as the substrate. It goes into the active site and the enzyme will perform the reaction. It will lower the energy requirement, allowing it to happen in the body, and then it will split out the product. So in this case, glucose plus galactose makes lactose. Okay. Now the opposite is true. Let's say you consume some dairy product, you just have some ice cream. Right? You will have lactose, and then you will need to have an enzyme that breaks down lactose, right? The enzyme that breaks down lactose is called lactase. So the lactose goes into the lactase, goes into the active site of the lactase. The enzyme will break the bond that's holding them, hydrolysis, right? And then it will split out the product. All right. People who don't have the lactase because their DNA is mutated, they cannot break down the lactose and they become lactose intolerant. Okay. Where do we get proteins? If you eat meat, anytime you eat meat, you would have proteins. Okay. Some has higher protein content than others, right? But generally, meat is meat. Meat is protein. If you don't eat meat, if you're vegetarian or vegan, you can get it from beans, right? A lot of beans like chickpeas, for example, kidney beans, right? Very rich in proteins. Soy product, right? Tofu, soy milk, they are all rich in proteins. Okay, nuts, lentils. All right, so that's where you get your proteins. You have to have proteins. If you don't have proteins, you can your body will become malnutrition, and then there's going to be a lot of problems associated with that. And beautifully, we end right at 2:20, exact same spot as this morning. Right? Sometimes I'm amazed at how robotic I can be with the time. So the quiz next week, like I said, is gonna be all of lecture 1 and all of lecture 2. We haven't finished lecture 2 yet, okay? But don't worry, we just have a few more slides to do. It will only take me half an hour for next class to finish it. We will also start on lecture 3 next week, so please print the notes accordingly. If you need extra help for studying for the quiz, or if you have any question, just email me and I will help you out. Other than that, thank you for coming again, and enjoy the rest of your week. Bye, everyone.